Hey everyone, welcome back to Scalar. So in this particular video, we are going to talk about agents and tools in LangChain. But before we get started, don't forget to subscribe to our channel so you don't miss the rest of the Agentic AI series. And if you are serious about building your career in AI, then do check out Scalar's Advanced AI and Machine Learning program, co-certified by IIT Roorkee CEC. It's designed to help you master the skill needed for the real-world AI role. The link is in the description box. Also, tell us in the comment what other AI topics you would like us to cover. So let's get started.
So let's try to understand what exactly is the agent. Now let's say this is my LLM, which is basically the artificial brain. So this is my LLM, and this is the artificial brain with two advantages. It can understand your natural language, so it has the capabilities of natural language understanding. I should have written NLU, not NUL. So it has the capability of natural language understanding. Plus, it can also perform context context based text generation. So this is what this LLM is capable of. Now, if I ask this LLM with a very simple question, let's say the question is, can you find cheapest flight from Delhi to Bangalore? Now, what do you guys think? Will my LLM be able to answer me this question? The answer is no. Your LLM is not capable of performing this kind of task. Your LLM can understand. Your LLM can understand that the user is willing to get the flights, the flight details. The LLM can understand that you want to fly from Delhi to Bangalore. Your LLM can also understand the date if I provide the date. So date of departure, date of departure. So this is something your LLM can understand and LLM can decode. But one thing which your LLM cannot do is the LLM is not able to execute this entire task. Now, the point is that how I can make my LLM conduct this kind of task. The only thing that I need to do is now somehow connect my LLM with one tool. And what this tool is going to do, this tool is basically the function which is connected with the API, let's say of Google Flights. So this is connected with Google Flights. So a tool in LangChain is basically a very specialized Python function which can conduct one specific task. As of now, let's call this tool as a flight search tool. And this particular tool is nothing but a Python function which is calling a particular API, and this API is connected with the Google Flights API. And this particular function, which is a tool, is connected with my LLM. Now, this is what the concept of tool in LangChain is. So, tool, a particular tool in LangChain is a specialized function that can carry out one very specific task. I can have a tool which can perform, let's say, a mathematics task. So, let's say I can have a tool of maths related queries. I can have a particular tool which can help me with the search operations or Google search. search tool. I can also have one tool, let's say, which can help me connect with my Zomato API. So all these are basically the tools which you can very easily create in LangChain, and we will talk about that in this video. But I hope you are able to understand what exactly is the tool. Now, once you have created the tool, you want to make sure that your LLM is able to connect with this tool. So for that, we use what is known as tool binding. Tool binding. Now remember one thing, your LLM cannot execute a tool. Your LLM is not capable of executing a tool. Your LLM, since it is a natural language understanding and context based generation model, LLM can suggest that for this particular operation, you can use, let's say, the flight tool, and then it can suggest the type of tool and can suggest the input to the tool. So it can also generate input to the tool. This is what your LLM can do. But your LLM cannot execute it by itself. Your LLM cannot execute a tool. So when you perform tool binding, you are basically providing the LLM with the context that this particular tool is available to you now. So once the LLM is aware about that, the LLM has the access to this tool, LLM can suggest that for this specific task, you need to use this tool. LLM can then generate the input that to that tool, and then you or the developer has to execute that tool and get the input to the LLM. So let's say I have the flight tool available to me. So let's say this is the flight tool. This one is a tool in LangChain. And please remember, a tool in LangChain is a runnable. This is a runnable. Runnable means this tool has a invoke method. So I can run this particular tool with the use of invoke method. And let's say this is the tool which can get me the flight details. And this tool is basically a API call. So this tool is doing one API call with the Google flights. So let's say this is what the particular tool is. Now what I have done, this is my LLM, and this LLM, what I have done is I have binded the tool, binded the flight detail tool, details tool. Now this LLM, I will call this LLM with tool. Now remember one thing, when I am doing a tool binding, I am not making the LLM control the tool. I am just giving the LLM with the context that now you have a tool available to you. So this is LLM with context about the availability of the tool. So this is what your LLM binded with tool look like. Now when I will ask this LLM a question, let's say, suggest me flights from Delhi to Bangalore on 25th December 2025. Now what this particular LLM will do, internally it will try to understand whether this query can be answered with the tools available to it or not. So first of all, what the LLM will do? LLM will try to solve this question without the usage of any tool. So try to solve or the answer the query without any tool. Now, as you know that LLM is not capable of carrying out this particular task. LLM does not have the access of any real-time flight data. So now the second step is LLM will now search whether the LLM is given with the access of any such tool. So check the availability of tools. Now, once it will check that do I have any kind of tool available to carry out this task, it will find out that yes, there is a tool named flight detail tool. Now, it will also check what is the description of this tool, and I will tell you how important is the description while you define the tool. So when you bind a tool with the LLM, you are providing a description about the tool to the LLM. Now, since the LLM has the description about the tool and the kind of input this tool will take as an input to execute, now the LLM is aware about the context about the tool, which is when to use this tool, also what kind of inputs this tool has to get in order to get you the result. So check the availability of the tool. Yes, there is a tool. It will be able to understand that there is a tool which is available, which is the flight detail tool. Now what it will do, the third step is it will send you the response. So this will be an AI response. And the AI response would be use tool. The name of the tool is flight details tool. And it will also suggest you the inputs. So let's say the input is KNP, BAN, Bangalore, and the date is 25th December 2025. So this is what your LLM will do. LLM will return you the AI response with this detail that it has suggested that you can use this tool and these are the input to the tool. This is what LLM will do. Now you must be thinking how this is helpful. Now what you need to do, you will take this input, you will take the suggested input and will take it to your tool. So take suggested inputs to the tool. And then what you will do, you will invoke this tool. Invoke. Once you invoke this tool, you will get the response. Now what you will do, you will again get back to this LLM. So you will again get back to this LLM with your original query, with the tool response. The tool response is basically this response. So this is what a tool response is. And now with this, your LLM will again process it because now the LLM has the original query. Now the LLM has the response from the tool. And what is going to be the response from the tool? It is basically the flight data. Flight data which the tool has fetched from the Google Flight API. And now based on the capabilities of natural language generation, it will be able to process the request, which basically mean it will be able to return you a well structured response. So this is what a tool calling looks like in your LangChain. You must be thinking that if you have to do it so much manually, then what is basically the advantage of having AI agents? Now that is what AI agents are solving the problem. As of now, what we are going to do, I will going to implement this entire agent, which I have just discussed manually. But in the next video, we will see that how the placement of agent in LangChain can actually solve all this problem, can solve the manual intervention. So you don't need to manually invoke a tool. The LLM together with the developer's function. So basically, in the agent, which we are going to talk about in the next video, so agent is nothing but your LLM with some tools, and in place we have some executor. So executor is nothing but a Python code, the code which is orchestrating this entire process, which we will do manually as of now. So I hope you are able to understand the concept of number one, tool. Number two is tool binding. These are the two major concepts that we will discuss and implement in this particular video. So let's get started and let's start coding it. So let's now implement the tool. Now in LangChain, we have some inbuilt tool. So I'll show you one very popular inbuilt tool. Now, this inbuilt tool has a very simple requirement, which is to perform search over internet. Now, we have a Google search tool also, but as of now, I'm going to implement and show you the usage of the search tool, which is DuckDuckGo. And this is very popular in LangChain. For this, you need to do a pip install of Google hyphen search hyphen results. This is like a backend tool which is required. What's the issue? Spelling ARCH. And let's also get the DDGS, which is DuckDuckGo search. I also need LangChain community. So let me just get all these three. Now from LangChain community, we will get the tools, and this is the inbuilt tool, which is duck duck go search results. Sorry, I want to run, not a result. I'll create an instance of this tool. So search underscore tool is equal to duck duck go search run, and then I can simply invoke it, as I have told you that a particular tool in LangChain is also a runnable. So recent terror attack, and there was a terror attack that happened in Australia. So you can see 4 days ago, Australia police. So you are able to basically get the search over internet results using this particular tool, which is DuckDuckGo. Now this is very simple. Like this, you can create multiple tools. We can create our own tool also, and we can then bind these tools with LangChain LLM. But this was your one example of inbuilt tool. How to create your own custom tool? So this is custom tool. Now to create a custom tool, we will use a decorator from LangChain underscore core dot, no, from LangChain we have tools, import tool, and this is a decorator. You just write at the rate tool, and after this whatever function you define becomes a tool. So I'll just simply create a basic math tool where you have inputs as operation, which is going to be a string, a, which is going to be a float, b, which is also going to be a float, and the output is also a float. Now this is very important. Now I know that you guys maybe not very much familiar with the way we have created a function in Python as of now, but this is very important. This is type hinting, and if you don't do this, your LLM will not be able to understand what is actually the definition of this tool. So I need to tell that this particular tool expects the input as operation, which is needed to be a string, input A, which is a float, B, which is a float, and returns a float output. Now I have to describe, I need to perform a detailed description about this tool. So this tool perform basic math operations. Operations are, let's say, add, you have subtract, you have multiply, you have divide, you have power, you have modulo. So these are the operations. A is the first number, B is the second number. Now you can add as descriptive detail as you want, but this is up to you. So if the operation is add, I want to do this. If the operation is divide, I want to do this. Let me just change one thing. I will raise error. One second. So if B is 0, I want to return cannot divide, return this, else LF operation is power. Yeah, ठीक है. So this is my particular uh, tool. Now once this is done, you can simply execute it and your tool is ready. Now since this is a tool in LangChain, I can invoke it. I can use the invoke method, which takes a dictionary as input. Operation is, let's say, power. Let's run it, and 2 to the power of 3 is 8. So we are able to understand this. Now you are able to also check some details of this tool. So if I say name, the name of this tool is basic math. If I say what is the description, then this description of the tool is this, which is exactly what I have written over here. And if I check the arguments, so basic underscore math dot args, and these are the arguments which I have defined over here. Now you are able to understand that why this was very much important, right? Now what goes inside the LLM when you bind it? So when I say basic underscore math dot args underscore schema dot model underscore json underscore schema. Now if you look into this, this is what exactly goes inside the LLM when you do the tool binding. So when I'm going to bind this tool with my LLM, this is what goes inside the LLM. So your LLM will be able to understand that this is what the description of the tool is. These are the properties, these are the inputs, this is what is required, title and the type. This is what goes inside the LLM. And once you are done with this, your LLM will be able to suggest this particular tool. So now what we'll do is, let's do a tool binding, a simple tool binding, so that we can also understand that how the output looks like. So if I say, so let me define the model. So this is my model. I'll say gm dot bind underscore tools underscore tools, and I want to bind. So there is a list which you have to provide. As of now, I just want to bind this particular tool, basic math. Let's run it. Acha, you have to also preserve it in a new variable. Let's call it as gm underscore with underscore tool, and let's save it. Now let's invoke this. So this is your LLM with tool dot invoke what's the multiplication of numbers 2 and 10? Now, can you see it has not given me any content? It has given me that it is a function call. Name of the tool is basic math. Arguments is b as 10. Operation is multiply a as 2. So this is exactly what we discussed, right? Your LLM is suggesting that you can use the basic math tool with the argument given as these. And this is what will be the output of your LLM with tool. So LLM with tool is not going to execute or is not going to invoke the tool. LLM is going to suggest that, okay, I have the access to this tool or the description or the context of this tool. And I am suggesting you that you can use this tool to get your task done. You as a developer has to execute and then provide the tool result to your LLM to further get it done. So this is what your tool binding is. Now, I know you guys must be thinking how we are going to do the end-to-end process. So don't worry. Let's create very good tool, not like a simple math tool. Let's create a tool and then let's create a full-fledged application by using tool binding. So first of all, what we are going to do is I'm going to create a tool which returns me the latitude and longitude of a particular location. So I'm going to create a tool for latitude, latitude and longitude, of a location. And the reason I'm doing it is because I'll tell you everything. I'm going to use a API, which is this one, Meta2. This API is a very good API. It is a free of cost. Like you don't need to pay for it. It provides you a variety of usage. It's a weather API also. It's a location API also. You can use it in a various ways, and it is free of cost. So you can read this documentation. You can create your account, and you don't need to create your account. It is actually free of cost. So let me import the library request because I need to run a particular URL, something like this to execute it. So request my URL is going to be, so let me create a tool for this from LangChain underscore, no, LangChain tools, import tool. I'm also going to import Pydantic. The reason I'm going to import Pydantic is because I want to create a tool which takes a structured input. So I'm going to create a tool. So right now this is only the type hinting. But what if you want a enforced schema? Then we can use the concept of Pydantic, which we have already learned about, right? So I'm going to import the base model and the field. And I'm also going to import request. Now I will create a class which is city input, which is nothing. You're going to inherit with the base model. And this will take city, which is going to be a string. And I will now define the detail of this field. So this field has the description, the name of the city, and someone can also provide a state or a country. So I can just only also write optionally with state or country. Okay. So this is done. Now I'm using the tool decorator to define the tool which is get latitude lon. It is going to take input city, which is going to be a string, and the output is going to be a dictionary. The only thing that I will do is, since I want to enforce a schema, while you are using this tool decorator, you can just mention this args underscore schema is equal to this, which is city input. Now this will make sure that you are able to enforce this schema in this particular tool. Let's define the details or description about this tool. So this is get latitude and longitude of a city name of the city. That's correct. Let's define the URL. So URL is going to be https colon slash slash. It is geocoding API dot open dot meta v1 such. Yes, this one only. Count is one, language is English, format is JSON. So this will remain default. Now I'm just going to invoke my response, which is request dot response is equal to request dot get URL parameters, my data response.json. So this is right. In my result, yeah, ठीक है. So basically your result is going to be a JSON file. From that we are getting the latitude and longitude in a form of a dictionary, which is the return. Let's run it. We can quickly check it. Dot invoke Kanpur. So you can see we have the correct output. So we are able to invoke this. Now what we are going to do, we are going to similarly create another tool which is going to get me the weather forecast of that location. So again, the inputs will remain the same. I am going to create a class which is weather arguments or weather inputs. This will take the lat and lon, latitude of the location, longitude of the location. That is fine. I will define my tool decorator. So tool, and here the schema is get. So the get weather information of the location. This is fine. Now we are again going to do the same thing. URL is equal to https API dot, yes, this is forecast. Current weather is true. This is going to give me a response. Response is equal to request dot get URL comma params is equal to params, and this will be a JSON output. I need to write that I want to return data. So let's check this tool also, get weather. So get weather dot invoke, and I am going to pass this a dictionary which we have. Oh, I deleted it. Let me run this again. Get lat lon of dot invoke city Kanpur. So this is what I will invoke over here. Okay, there is a problem. Okay, the problem is that it needs to be lat, not latitude, and it's need to be lon, not longitude. And here you can see we have the result. So for this, we have the entire result. The temperature, wind speed, everything is available right now. Okay, now our task is not done. I have to bind this tool with my LLM. So let me get my LLM. Okay, so this is what I'm going to use as of now, my Google Gemini model. and I'll say gm with tool is equal to gm dot bind tool, and I'm going to provide the list, the latitude, longitude, get weather. So this is done. Now if I invoke this gm with tool invoke, what's the weather in Kanpur? Let's see the output. So we need to check whether my LLM is able to call the tool which is required. First tool which will be required is the get lat underscore lon tool. Now this tool will get me the latitude and longitude of this city Kanpur. So it is taking some time. Let's wait. Okay, so I have exhausted my credentials. Let me use the OpenAI. So here I'll just say LLM, and here I will say LLM with tool. Okay, sorry. This will be LLM with tool. So here you can see that the tool call is get latitude longitude for the city Kanpur, India. And this is the first tool call, which is what my LLM is suggesting. So what I'm going to do now is I'm going to iteratively execute this, but there should be a process. I cannot just do it by simply copy pasting. There should be a iterative process. So the first iterative process is I'm going to create a human message where I'm going to preserve my question. So from LangChain underscore core dot messages, I'm going to import the human message. And the next thing that I will do is I will maintain a message list where my human message would be the question, what's the weather in Kanpur? That's my input. Now I'm going to invoke my model, which is LLM. So this is my user query, which is appended to a message history list. Now, next thing that I will do is I will invoke LLM to get tool call. So I'll simply say result is equal to LLM will tool message. And let's see how the result looks like. Now result is, what is the problem? Runnable binding object is not callable. Okay, sorry. I'm really sorry. I should have written invoke. So invoke this messages. Let's see. Now this is what the output is. What I'll do is I will append this in my messages history. Append AI message into the history. And I'll simply say messages dot append result. Now I have to execute the first tool. Execute the first tool to get lat and lon for the location using tool call. So I'll simply say my lat underscore lon call, which is tool call, is equal to result dot tool call. Now, if you just simply run this, let me just remove this tool call, you'll be able to see that this is a tool call. And if you use square bracket 0 to get it out of the list, you'll be able to get the dictionary. Now you can pass this entire dictionary to your tool. So what I'm going to do is I'm going to preserve this in a variable lat underscore lon underscore tool underscore call. And now I'm going to invoke my tool, which is my tool name was get lat lon dot invoke this. Now this will return me a particular result, which will be a tool message. So let me show you this. So this will be a tool message, and the output is it is latitude and longitude. So this is a content of the tool message. I'm going to append this in my LLM again. So I will say message dot append this. So now the tool message is also appended. Now I'm again going to invoke LLM with tool to check the next tool call. So I'll say result is equal to LLM with tool append message, sorry, invoke message. Let's see. So what is my result now? Now this is the second output from my LLM. Second tool call is get weather. Latitude and longitude is suggested by the LLM. So again, I will do the same thing. First, I will append this into my append second AI message. Second, okay, AI message into history. And then, so let's message dot append. And then I will invoke my second tool. So second tool is yes, get weather invoke. Okay. So this is correct. Now I will again invoke LLM to get final result. So I'll simply say, let's run this. I'll just show you, or maybe ठीक है. And here is the result. The current weather in Kanpur, India is as follows. Temperature is 15.4 degree, wind speed, wind direction, weather condition partially cloudy. And please note the weather condition is subjected to change. So this is what we have done. This entire process is now basically manual, you can see, but you are able to understand, right? Based on the discussion that I showed in the start of the video, I hope you are able to relate to it. LLM is not controlling any tool. LLM is just suggesting that you can use this tool with this input. Now you as a developer has to invoke that tool manually, and then you again invoke the LLM, you again invoke the tool, and you get the final answer. So the problem with this approach is that first of all you are orchestrating the entire process, which is what I don't need as a developer, right? I need some automation, I need some uh, process where I don't need to do it, and LangChain has understood this. So that is where the next concept which we will talk about is how to create agents out of it, how to create those agentic AI where all these processes happening internally by the LLM framework, and you don't need, sorry, by the LangChain framework, and you don't need to do it. So exactly this is what going to happen, and I'll show you the message which we have, with message history. Remember one thing, the message history should always follow this iterations. Human message is the very first message, then AI, then you will get the tool message, then again AI, then you will again get the tool message, and finally your AI. So if you don't follow these tags, which is the message tag, your LLM will not be able to execute it. It will throw you error. So you need to make sure that your history that you provide to the LLM follows the structure, and this is the structure it will only take. And this is what will be the same process that you will see in the next video, which we will implement, but using the LangChain framework, which is create agent. So now the entire heavy lifting that we have manually coded is going to be done by the LangChain create agent framework, and you don't need to do it. So I hope you guys are able to understand the basics of what is agent, what is a tool, and how to bind a tool and how to call a tool. In the next video, we are going to look at how to create agents. And basically, we are going to create a full-fledged agent, which we have talked about in the start of the video, that is the flight suggesting agent. So that is all about this particular video. I hope you enjoyed. We are about to end this series with one more video coming in. And that is going to be a very exciting video because we are going to implement the entire project. But I hope you enjoyed this video. Please like this video. Share this video with your friends, those who are looking to upskill in the field of generative AI. And I see you in the next video.